Hi guys, Mr. Lees here doing the SQA Higher Mathematics paper from 2019. We're on paper 2 and we're doing question 15, where you have a circle, centre 8, 12, and you have a point 5, 13 lying on the circle, and we have to get the equation of the tangent at P. So we're going to get the gradient from C to P, P to C, and then we're going to get the gradient of the perpendicular, and we're going to use y minus b as mx minus a using 5 and 13. So let's just get on with that there. So there's your P and your C, the gradient from P to C. 12 take 13 over 8 take 5. 12 take 13 is minus 1. 8 take 5 is 3. So therefore the gradient of the tangent has to be 3, because 3 times minus 1 over 3 gives minus 1. So you have a tangent with a gradient 3 going through the 5, 13. That's the point P. So y minus b, y minus 13 is m, 3 times x minus 5. Multiply through that, you get 3x take 15. Tidy it up by moving the minus 13 over to make it a plus 13. And this gives you y equals 3x take 2. Just made a mistake there. Y equals 3x take 2 is your answer there. So that line there is the line y equals 3x take 2. And then for B part 1, state the coordinates of t. Well, we already know the x coordinate of t is 0. And we know the equation of the line. Therefore, we can work out the y coordinate. So that's the equation of the line we've just got. And when x is 0, y is 3 times 0 take 2. So y is minus 2. So t is the point 0 minus 2. And for part 2, there, find the equation of the circle that passes through the point C, P, and T. So, if I can just get you to cast your mind back to National 5. So this is actually what's happening here. If you have a line that is a diameter of a circle, and there's the centre, and you draw the circle around it, and you have another point on the circle such that C to P to T is drawn out as a triangle, then because that is on the circle, that means that that is 90 degrees, and therefore we have a circle going through all these points here. Now that is exactly what's happening here. If I just draw this out here, so here is the diameter from C to T. There you have the point C to P. That's the one that I was using earlier on. But C to P to T is 90 degrees. So P lies on this circle that goes through C at one end of the diameter, P on the circle, and T is at the other end of the diameter here. So this is what is happening here. Here is the circle that I've just drawn out there. So the centre of the circle is halfway between C and T, and we'll get the gradient, we'll get the radius, sorry, in a wee second there. So let's get on with the work there. Now, there's a quick way to do this, so I've obviously alluded to there being a very slow way to do it. Anyway, let's get the midpoint from T to C. So 0 add 8 is 8, half it, you get 4. Minus 2 add 12 is 10, half it, you get 5. So that's the centre of the circle there that you will have seen that I drew just a wee second there. So there's the 4, 5 that I showed you earlier on. And the vector, the distance of the radius is the distance from 4, 5 to 8, 12. So let's get the vector from 4, 5 to 8, 12. 4 to 8 is a jump of 4, 5 to 12 is a jump of 7, and to get the radius is the length of this vector, square them, add them, root your final answer. So the radius is root 65. So we have a circle centre 4, 5 with radius equal to root 65, x minus a squared, x minus 4 squared, plus y minus 5 squared equals root 65 squared, 65, and there is your final answer. Okay, so that's that one done. So if you want to stop, that's fine. But there might be one or two of you not managed that. And can I just point out as a little lesson here, if you have 3 points on a circle, To get the, if you get the perpendicular bisector of 2 points, and you get the perpendicular bisector of another 2 points, the equation, find where they cross, that is the centre of the circle that goes through these 3 points. So this is going to take a little bit of time, but this is for the people who didn't manage what I talked about just a wee minute ago. So this is essentially find the equation of the circle that passes through the points P, C, and T. So we're going to get the perpendicular bisector of PC. So we need the gradient from P to C, which is 12 take 13 over 8 take 5. And this gives you minus a third. So the gradient of the perpendicular is 3. And the midpoint of PC, now remember with a calculator, 5 plus 8 divided by 2, 13 plus 12 divided by 2, 25 over 2. Doesn't look good, but we've just got to crack on it. So with a line, gradient 3, going through 13 over 2, 25 over 2. So y minus 25 over 2 is 3 times x take 13 over 2. Multiply that out, 3x take 39 over 2. So y take 3x is minus 39 over 2 plus 25 over 2. So y take 3x is minus 7, and that's the perpendicular bisector of PC. Now let's get the perpendicular bisector of between two other points, and I'm picking P and T this time. So we're going to get the perpendicular bisector of PT. So same again, minus 2 take 13 over 0 take 5. That gives you a gradient of PT to be 3. So the gradient of the perpendicular is minus a third. The midpoint of PT, 5 add 0 is 5, half it. 13 add minus 2 is 11, half it. And the gradient is minus a third. So y minus 11 over 2 is minus a third times x minus 5 over 2. I've just chosen to multiply this by 3 and multiply through by minus 1. So we've got 3y take 33 over 2 is minus 1x plus 5 over 2. So 3y plus x is 5 over 2 plus 33 over 2. So we have 3y plus x is 19. So we have two perpendicular bisectors, and we can solve them together to see where the centre of the circle is. So we have y take 3x is minus 7, solving with 3y plus x is 19. I've chosen to multiply this by 3 to give 9y plus 3x is 57. Just bring that down, and we have 10y is 50, so y is 5. And then we have 3y plus x is 19, 3 5s are 15, plus x gives 19. So the centre is 4, 5. Okay, so I admit it's a long way, very long way, to get the 4, 5 that we got so quickly earlier on, the midpoint of TC. But anyway, that's the centre of the circle. And then we just use the distance formula from 4, 5 to 8, 12, just like we did earlier on. This time I'm using the distance formula. 8 take 4 squared plus 12 take 5 squared. And that gives you your 4 squared and your 7 squared, and that gives you your root 65. So we have a circle, centre 4, 5, radius root 65, x minus 4 squared plus y minus 5 squared is 65. So again, you'd only be doing this if you were really, really stuck, maybe at the very end of the paper. Okay, there we go.